lot of calls on, it's probably the #1 request in any renovation, and is that, can we take this load down? Can we take this wall down? The answer is absolutely, but there's a lot of things to consider, and I'm gonna go over a few of those things in this one. What we're doing here is we're taking this whole wall down. It's about 24 feet, so it's gonna take special engineered lumber, and that lumber is very, very big. There's 3 loads here. We've got a load in the center here that's got to come down, and what we've done is put up temporary bracing to brace our rafters and ceiling joists so we can get them in that attic while we take down and redistribute that load. There's a second one across the other half of the kitchen, and then you're taking this main wall structure out. So the rule of thumb is, and actually the law is, if you don't touch it, you don't have to fix it. But the minute you touch it, you got to bring it up to building codes. In 1989, a tree fell on this house, and the rafters split, and they basically just attached wood to the side, it's called sistering, to where the rafters broke. I can't leave it like that, I've got to fix it. So that's one of the things we're going to have to address, because now we're touching this. When we opened these walls, we found out that the header is not actually supported. So when you frame in a window, you've got a jack stud and a king stud. The jack stud is what the header sits on. The header takes those rafters and moves it out to here, takes it down to the foundation. That way you don't bow your window, you don't put weight on your window. This was a really interesting find because these jack studs do not go all the way to the header. In fact, they've just got these wood blocks in there, which I pulled out. So there is no load transfer going on here. Now, if I don't touch it, I don't have to fix it. But we're making these windows cabinet height, so I'm gonna have to reframe all of this for modern building code. Talking about removing walls in general, load bearing and non-load bearing, it goes for both. You gotta pre-plan and think. You wanna take the wall down, not only do you have to deal with the load, but you have to consider what is the floor on both sides and how are you gonna patch that or make a new seam. The other thing you have to think about is air vents. If those air vents are connected to each other, do they meet modern building code if you remove them or relocate them? And electric's a big deal. People overlook a lot of the time. You can have receptacles. We don't have any here, but they're on the other side. In this space, what they'll do a lot of the time is run my power there and then go under in the basement and run a receptacle there out of that box. If I remove this wall, I don't have power in that receptacle. So if the basement's finished, I gotta open the basement ceiling to fix that. So those are some of the expenses you got to think about when you're removing walls. So in redesigning this home, in the 40s everything was very compartmentalized. Well, what we want to do is open it up. We already talked about taking this whole wall out, but what we're also going to do is open this stairwell. We're going to take it back as far as we can, and what that's going to do is you enter, not only will you be able to see the kitchen island, you're going to be able to see straight back to this amazing backyard through a brand new plate glass window that we're putting in. The staircase in an old home does not conform to modern building codes. And again, the rule is if you don't touch it, you don't have to fix it. If I wanted to change that, I would have to follow modern building codes, and the structure of this house isn't going to allow for that. So what we're going to do is paint the stairs and not change the treads, because currently they've got a 9-inch rise, which is too high, and they've got a 34-inch width, which is too narrow. So in these old homes, the laundry is usually down in the basement. Now, as people age in their homes, which is what we're planning here, is for the client to age in her home, they want that laundry brought upstairs so they don't have to go up and down stairs. First thought is, let's stick it in a closet. But 99% of the time, that closet's not going to work because it's not deep enough. This one's only 34 inches. If I put it in this closet, I have nowhere for the air vent, the HVAC ducting, to exhaust out properly. What we're going to do is use the closet in a different direction. This is a rare circumstance. I don't see this a lot. We're going to take the door, put it over here, and that will give us the depth that we need to facilitate that request. In these old homes, if you find a gym like this, the doors are pristine. The homeowner's been here since, I think, the 70s, and she's kept a beautiful home, and all the woodwork's in really great condition. So what we wanted to do is reuse some of these doors. While the door's in the wall, you can actually put braces across it. When you go to put it in a new place, it just slides right in the wall and everything is square and level and plumb. So then the door goes back on. You actually save a bunch of time trying to re-level this frame. So since we're reusing things, that's one of the tricks that we definitely used here. So in an old home, they used a lot of stain grade wood. Everything was stained. So it gets to be a little bit overwhelming. But if you use it strategically in a renovation, you can really change your design aesthetic. This trim doesn't exist anymore. I could fabricate it, which would be very expensive, but what we did is we did a selective demo and took the nails out. We were very gentle with it. Now, all these nail holes and stuff are gonna have to be dealt with, but what we're gonna do is keep the natural wood doors and then paint all the trim white. And what that's gonna do is really make the woodwork that's left in here pop. Framing then and framing now, they're different, but we get the same result. If you frame a 2x4 wall, there's nothing to keep it from going side to side. You've got your top plate, your bottom plate, and then your studs, so it could easily fall left or right. Well, these angle braces that they put in the corner back then actually stop that from happening. The minute you change that angle of that brace, it becomes very rigid. They did it on both walls. So today what we would do is use plywood. The plywood is our brace that basically keeps the house from rocking and racking. If you look at this text here, it actually says this is moisture repellent gypsum, which is essentially drywall, which is not enough to stop that. Today we would use plywood. This is not real sheeting, it's just a backer for the brick. In addition to that, anytime you cross your angles in a framing project, you increase the structure strength. And what they used to do in the floors is they'd run these boards on an angle at a 45 degree across. So the more times those wood elements cross angles, the strength increases. What we would do today is OSB sheeting across the floor, which again, not the same angle, but same theory, it creates that strength and rigidity. Another bathroom renovation. If you know me, I love bathroom renovations. Old homes present old challenges. You can see how this wall's built out. That's because you had to use a cast iron pipe back then. That was really the only way we could vent the sewer line. And what that means is if there's no air coming into the sewer line, the water can't flow properly. So you've got to have air coming in and the water going in, and that allows the water to flow properly. So we don't have to keep this anymore. We can go back with a 2-inch vent pipe. So we're going to reframe this wall to push it back and everything's one level. If you know me, you know I don't like plaster. I deal with a lot of plaster. I really don't like dropping plaster ceilings. It's the summer, it's getting ready to be very hot, it's going to drop old insulation on us, and then this space is going to be very hard to work in. So you can see this metal lathe around the corners. We're going to cut that off and just overlay this with new 1/4-inch drywall. You'll never know the difference. If there's any cracks, it'll take care of those cracks. Anytime you demo an old house, you really want to be careful with what you're tearing out. You want to get proper tests done, asbestos and lead. Anything before 1978 legally needs to be checked. We really go further than that. So anything that was built in the early 80s, see, there was a bunch of lead paint left over and people kept using it. They didn't just throw it away. So legally it's 1978, but we like to really test things into the early 80s. In this instance, we see on the floor what looks like asbestos tile. It is not asbestos tile. And the way you can tell, you can't tell, but the professional can tell, is when you break it, there's actually little hairs on it. So we can actually break a piece of this and show you that there are no hairs on it because our professionals already did that for us. In an old renovation, we like to keep things that are original, that are in great condition. This tub is in immaculate condition, so we really wanted to keep it. The new trim for the drain that goes in the tub is smaller than the original trim that went in the tub. So you have one of two options. You can either spray the tub, which it's not going to last that long. I don't recommend doing that. I'd just pull the tub out if that's my option, and for $1,200 you can put a new tub in. But in this case, what we're going to do is match the existing metal. The metal was in good condition. We're just going to match the metal, and then we can keep the original tub and leave that retro look. In 1947, when this house was built, we had the big A, asbestos. We pulled up the carpet, we found asbestos. It's in good condition. It's not flaking up or causing a problem. It's not becoming airborne. We had it tested. We're certain that it's asbestos. So you've got one of two options. Either remediate it, which this small space would probably be about $4,000, or don't touch it and cover it up. So budget-friendly option is to use luxury vinyl planks. It'll go right over this and it'll be encapsulated. This house has a really cool feature, and that's a swimming pool. And the only way to get to a restroom is to go up the stairs to the second story and use the restroom. So what we're gonna do here is right off the pool is put a half bath. We'll put a wash-off shower outside, but this will really help with the resale appeal of this house. We've got paneling on the ceiling, which we don't want to disturb. We're just gonna paint it white to lift it up, but we can't get to a sewer line going up, obviously, due to gravity. So what we're gonna do is put in what's called a sealed sewer pump. So we're gonna cut the concrete, put in our sewer lines, and take it to that side of the house where we can pump it into the main line. Something a lot of inexperienced people overlook is complete transfer of the load. The load has to go from the roof all the way down to the footers or foundation of some type. So you could take the wall out and put a beam in, but without transferring that load all the way back down to the ground, it's not safe, and you definitely should ask somebody if they're not doing that. Find out why they're not doing that. I hire an engineer, the engineer tells me what to do, I follow his blueprint, and you're gonna be safe if you do it that way. How we're gonna deal with transferring that load is, we'll put our beam upstairs, we'll take our framing down to the first floor, and then we'll take steel posts down into new footers that we'll have to cut this concrete and pour a footer based on what the engineer tells us to do. We're removing all the load-bearing walls upstairs. We're redistributing the load down through the basement. Here we're at the footer that the engineer gave us a plan for. We put the metal reinforcement inside of it, and this footer is actually a little smaller because it's sitting on the original house's footer. So we were able to minimize that. The ones across the basement that are transferring the rest of the load are quite a bit bigger. He had spec'd using a wood member here to frame it up, and we asked him if he'd be okay with us doing metal. Of course he was, because that's better than what is required. The building code is really there as a minimum requirement, and we really try to do a few steps above that if possible. So build better than you have to. In one of our previous videos, we talked about moving the laundry from the basement to the upstairs, which we have done. We've got it in a closet upstairs, and the plumbers needed to get their 3-inch line right where our ducting was. What we did here is we removed the existing ducting lines and had our HVAC guy come out, take measurements. They're actually going to fold metal around this pipe to accomplish what we need to get done. We've got our temporary walls in. We're getting ready to bring our LVLs in so we can start framing, and then we'll cut all of our temporary walls out, and that load will kind of settle down onto the new footers. What we did is we beefed up this structure of these split rafters. Originally it was just a 1x6. We put a 2x6 on, we glued it, and we used construction screws. You can always do the minimum. We do better than the minimum because it's just our practice. We hired an engineer to tell us how to take this roof apart, and his plan was to use these LVLs to redistribute the load and open up the space. We have removed this window, which is not going to be needed in our final design. We're going to brick it up on the outside, but temporarily we are actually going to move our lumber through this window because they're 24 feet long by 18 inches high, and that's the only way we can get them in without pulling the roof off. Once we have those members in this room, we're going to rest them here, transfer the load down to those steel posts that you saw, and back on that side, 24 feet back, it will do the same thing to steel post onto bigger footers. So you hear me use the acronym LVL a lot, and what that is this big laminated veneer lumber is what that stands for. It's 18 inches by 24 feet long. And the way it's engineered allows us to remove walls and go longer runs in a room. You could see that the framers were here yesterday. This is what it took to open all these walls. It's a lot of work. We had to take the two 18-inch LVLs, screw them together, do it in 2 different locations, and then transfer the load back with 2x10s and joist hangers. So this is what the space is going to look like opened up. We're getting rid of this wall. We just have a little bit more work to do here. Keep watching and you'll see the evolving. If you've been in these old homes, or you own one of these old homes like they do in Buena Vista here, they've got what's called a 2-wire system. There's only 2 wires in this outlet. There's a hot and a neutral. There is no ground wire. Most of our computer plugs, appliances have 3 prongs on them. So what I see people do a lot is replace this with a 3-prong outlet and not take the proper measures to make sure the electrical wire is rectified. So you can either rewire the house, which is kind of expensive, or you can get a qualified electrician to put in what's called a GFI breaker. Then you can swap this out with your 3-prong outlet and use your modern appliances. So one of the hot trends, as you know, is open shelving. A little addition to this open shelving, we're actually gonna route out the bottom of the shelf and put a LED light strip in it. We fabricate the steel rods, put them behind the wall, finish the sheetrock. Everything's measured out so that the electric wire comes out in the right place, and it should be a real nice finished look to this wall. We had the walls open. You could see that there was no insulation in these walls originally. The plaster served a little bit for R value, but not like modern insulation. We went back with a modern insulation up to current building code. Now, we talk about going the extra mile. There are small air voids behind electrical boxes. What we have done is gone behind them and sprayed foam behind them to get that full R value. So we like to go the extra mile, and that's one of the ways we do it. When you build in different places, you have different building codes to follow. If you build at the mountains, it's different than building at the beach. Building here in the Piedmont Triad, we have certain codes that we have to follow. In the walls, we use an R15. It's called the R value of the insulation, and it has to do with the thickness and the way it reflects heat in and out of the building. In the ceilings, we're required to use an R30, but in an attempt to build better and for a few pennies more, we upgrade all of our ceiling insulation to an R38. It just adds to a better product in the end with a little bit more R value, and all of that matters in today's society with our heating and cooling. So we've talked a lot about going above and beyond what we have to do. Now, when we insulate, one of the things that we do is caulk the space between these studs, because there is a small air gap between them. And each little step you take to prevent any heat escaping or coming into the house gives you a better sealed structure. We've talked about building better and going the extra mile, and you may be able to get away with not insulating around the windows, but in our attempt to create the best product possible, we take that extra step and fill all the gaps around the windows with foam to create a better R value overall. So when we frame a new house, we use plywood subfloor. When they framed this house, they used a diagonal 1x across the whole house, which prevented the house from racking, which makes it twist like this. This adds to the stability. Then they would come in and run their white oak over this. This whole house has white oak in it, except for this floor. They had some kind of linoleum variant in it. So we want to continue the hardwoods through this whole space. Now, the rest of this floor under these hardwoods is not screwed down, but in an attempt to build better, this was exposed, so we have screwed this down to eliminate any possible squeaks in future floor in at least this area. So I want to talk a little bit about nail guards. This is a tool that we have for electrical and plumbing and HVAC if it's needed. Any kind of penetration through a stud needs to have a nail guard on it, so when we go to put baseboards down here, we don't shoot nails into that plate, and we don't shoot it in here when we're hanging drywall. This is a nail guard which will prevent us from causing damage to the plumbing fixture or the electrical. So if you don't touch it, you don't have to fix it. But this scope of work included adding a basement bathroom. Now the basement bathroom directly ties into an existing laundry room. The existing laundry room is not up to building code. So in order to add the bathroom, we have to update the laundry room. Now the bathroom is actually below grade, which means it's below the sewer line going out to the street. So the only way to get the waste out of the bathroom is to go under the concrete into a sewer pump that ties directly back into the main drain and goes out of the house. It will eject the waste out of the house into the sewer line. So drywall mud typically comes in a bucket, and then you have to mix it and put it on the walls. Well, if it's humid outside, sometimes that drywall mud takes a lot longer to set up, so you can put the next coat on. This is a product that sets up much faster. It's a Quickset drywall mud. You have to hand mix it. It's a powder. There's 20-minute, 45-minute, and then there's a 90-minute. So based on what this bag tells you, you've got that much time before it starts setting up, before you can't work with it. The lower the number, the harder it sets up. So you got to be really good to work with this stuff, because the lower the number, the harder it is to sand. So you've got to put it on the right way. So I want to talk about a level 5 drywall finish. Traditionally, what we do is just finish the seams and the nail holes in drywall. In a level 5 finish, we actually cover the entire ceiling in drywall mud. What this does is, as the light changes throughout the day, it minimizes any variances in an old home or a new home where the framing may show the imperfections in the drywall. Before we had modern air conditioning, we had whole house fans. These are very popular in this area. If it was a nice night out, you could crack your windows, turn on the whole house fan, and it would just suck this cool air through. It'd cool the house down, and then in the morning you'd close the windows and you'd have a nice cool morning to start your day with. They're very, very effective, but they're not very efficient. This homeowner grew up with them. She loves them. She wants to keep it. She's actually going to utilize the function, which is great. But in most situations, we're actually pulling these out because a modern air conditioner is actually more effective. In these old homes, there's a lot of times in the design that we have to change a window opening or close it altogether. In this situation, we had to shrink it. This house was actually built in the 50s with reclaimed brick from a century before that. It's nearly impossible to find a brick in today's brick yards that's going to match that. Luckily, the homeowner had a retaining wall that we could pull apart, clean the brick, and piece it in so that it matched the original brick. There are certain requirements on the size of a window or the location of a window and the distance off the floor that it's required for that glass to be tempered. Tempered glass is much harder to break. So given the size of this, this was actually required to be tempered. If it's a certain amount off the floor, it has to be tempered. And if it's in a shower, it has to be tempered. And the way you can tell if they've done it right is there's a little etching in the top or bottom, this one has it in the top, that dictates that it is tempered. So be on the lookout for that. In a renovation where you're going to meet old wood with new wood, you have two choices really. You can either run a transition strip down the center or you can lace it in. Now, if it had just been a doorway, I would have chose to lace it in, but because you walk in that front door and you've got this big open area, you run the chance of the old wood and new wood looking like a zipper going down the center of this room, ruining your whole effect. There were two walls right here which tied into the hardwood floors, so we had to use a technique called lacing, where we had to go back and cut out pieces of the wood to marry it into the new wood and make one cohesive space that looks like it was always there.